Hi guys, I'm going to teach you how to write TCP IP code in a messenger in C. But before we get started, I will teach you how to do this using netcat. If we want to specify a server, we will use a -L flag to listen on the interface in the port, such as this. And if we want to run a client, we will just pass in the IP address that we want to connect on and the port address, the port. Hi, I'm the client. And the server received the message, and you can also write, "Hi, I'm the server, goodbye, goodbye." A few things to notice here is we can write as many times as we want on each side. This is because this server and client structure is using non-blocking sockets to make this work. And in my tutorial, I'll focus on blocking sockets, and in the next tutorial, we'll focus on non-blocking sockets. So let's go ahead and exit out of here, and let's get started. The first step is to write a main.c file and to decide on the structure of your program. In my case, I will call the messenger, and I will expect the first parameter to be passed in as either server or client, followed by the IP address and the port. For the server, the IP address will be the address to listen on, which when all zeros means listen on any interface, and when it's the local host, it will mean you only listen on localhost, which is great for debugging, and this will be used for production purposes. In my main function, I have a server requested and a client requested variable, and I also have an IP address and port. So the first step is to check if there is less than one or less arguments passed in. There will always be one, because if this is the first messenger, it has to be the first one to call the program itself. So if there's one, then we will print the error message. Next, if there are two arguments passed in or more, we will check for server or client and set the corresponding variables or flags in our case to 1. Otherwise, we'll print an error message. If there are 3 arguments or more, we will set the IP address, assuming it will be the IP address passed in, since that is what we specify for our interface to this program. And the 4th argument will be the port, such as 21,750. Next, if server is requested and the IP address is not null and the port is not null, then we will run the server with the IP address and the port that was requested. Otherwise, if the client is requested, and again the IP address and port are passed in, we'll run the client and afterwards return 0. Otherwise, we'll check if server is not requested or the client is not requested or the IP address or the port is not passed in, then we'll print an error message and we'll exit. Let's now figure out how the run server function works and how to use TCP/IP for this. Inside of my files, my structure is set up to have an include directory and a source directory along with a make file. So let's open up server.c. And let's also open up the TCP socket helper. And this one. So the first part for run server is to understand that it's getting an IP address and the port number as a string. The next part is we will create a server parameter struct or argument. And in my case, server parameters is defined, let's see, right over here. I defined it as the socket file descriptor and a struct sock address and server address. And you can separate these out, but I find it easier to keep the socket file descriptor and the struct that has the server address together. Just makes passing things back and forth easier, and you get to know the IP address of everything. Inside of here, I have defined a type def to define the struct server parameters as server parameters. That way I don't have to type in struct every single time I want to use this. So this is the way I set up my projects for C, and it's a very neat way of doing it. We also have an init server parameters to initialize the struct, because we always want to keep things initialized. So we call the init server parameters function, which will, again, it's right here. It will just set the socket file descriptor to -1. I want to set it to -1 and not 0 because 0 is a valid file descriptor and it usually means standard input. So we want to go with negative numbers and just use memset to clear out the server address and get the address of it. The next part is to get the IP address numbers from the IP string. And to do this, I have a helper function that I wrote, and it will take the IP address as a string that was passed in by the user and a pointer to our variable, which is the IP number in network order. And mentioning network order, there are two ways we can do this. A number can be stored in little endian or big endian. The network order uses big endian, and an architecture might use little or big endian. And for example, for x86 and Intel based architecture, they use little endian. So we want to clarify whether we are using network order or host order. Or in my case, I specify that it is network order, and it is the way I define my function. So let's look at this function right here. So I specify I get the IP address number in network order, which is what will be returned. So if the IP is null, we'll return -1. And if the IP address number network order, the pointer to it is also null, we'll return -1. We just want some basic error handling. Next, there are two ways of doing the conversion of the IP address, the string to a number. And the old and bad way is to use inet address. So for example, if I comment this code right here, we can define an IP address number and just simply call inet address to get the IP address. There is a tiny bit of error handling involved in this function, which is simply checking if the return value is in address none. However, the problem with this is that in address none is equal to -1, which is equal to OX FFFFFFFF, which is equal to 255.255.255.255. And the issue with this is that this is actually a valid IP address. So if you were to use this code and pass in this IP address, you would actually run through this error handling and return -1. So inet address is limited because you cannot accept this as a valid IP address. So I would recommend not to use it. Instead, we can use inet ASCII to network order. And the nice thing about this is that it takes an IP address and an IP address is returned. So this is the input, this is the output, which is defined right here. And it returns whether the IP address is valid or not. So I can check for if not valid, print the error message. and return -1. So this will allow us to use some nice error handling and ensure we get a valid IP address from the user. So if the IP address is returned as valid, we will go ahead and assign the IP address that was returned from inet.aton or ask-it-to network IP address .s address, because this is a struct itself, and return it to the user. Return 0 to signify that everything returned properly. I will try to use the Unix convention of returning 0 for success as much as possible. So if return is not equal to 0, we return -1. And if it is 0, we continue on since we know we got a successful IP address. The next part is to convert the port number into an ASCII. And again, you can use the old and simple method of using ASCII to integer and just convert the port number to the port number. But again, there's limited error handling because if there is an error, it will just return 0. So instead, I prefer to use the strtol function. And in this case, we can set the error node to 0. We need a variable for the port endpointer, which is passed into our function. And we also need to cast this into an integer since a long int is actually returned. So if error node is not equal to 0, that means we got a failure. So we'll just go ahead and print it. Next, we need to check if the port endpointer is equal to what we started with. This will also mean there's a failure. And also if port endpointer is not equal to the null character, then there were invalid characters detected in the port string. So we again return -1. At this point, we know that we have a valid port number, and we just want to verify that it's greater than 0 and less than 65,535. However, if it's less than 0 or greater, we want to print an error message and exit. So at this point, we know that our port number is valid, and so is our IP address. So let's go ahead and convert the port number into network order. And for that, we need to do the host to network short. So that's what the HTONS means, host to network short. And the short means it's a 16-bit number, which is what the port number is, because 16 bits is what's required to be between 0 and 65,535. After this, we will want to call our configure server function, and this will take server parameters, which was our server parameters function or struct that we declared. And the next part is the IP number in network order and the port number in network order. So let's go look at this function, configure server. So the first step is to call socket using AF-INET, which will mean it is a TCP IP. Actually, it means selects the IPv4 Internet protocols. Sock stream selects TCP IP. And 0 isn't required in our case, so it's 0. If we want to take a closer look at socket, we'll understand that this actually means the protocol. And when you use sock stream and TCP IP, the protocol is just 0 because there's just one protocol. So let's go look at the man pages for socket. So the domain, like I said, was AF-INET, which means IPv4. The type is sock stream for TCP IP, and the protocol is just 0 because there's just one protocol. When you use socket, you can create different types of networking interfaces, and that's why there's a protocol for cases when there's more than one type of protocol that is supported. So socket will return a file descriptor for our socket. And we want to just make sure that it is greater than or equal to 0. If it's less than 0, there has been an error. The next part is to call setSock option and to use the reuse address flag and also setSock option for a reuse port. We want to ensure that if our server dies, we want to restart it. We can restart at any time instead of waiting for a timeout for the port or the address until we can use it again. So if we want to look at where this is defined, we can again consult the man pages. For example, and if we take a closer look through here, let's actually look at the start. So the socket file descriptor, which is what we created up above using socket. The level is usually specified as source socket, and the option name comes from, let's go find it. So yeah, for a description of the available socket options, see socket page 7. So man 7 socket. And it's right here. And it supplied it. So should allow reuse of local addresses. So that's what we want when we do a lot of testing, is we want to be able to reuse the addresses. And the value needs to be passed in as a pointer. So we make a variable for value, whether it's being set or not. So if this was 0, that would mean we are clearing this option, but we want 1 to set this option, and we need to pass in the size of the variable because, again, setSock option works on many different types of functions, and it needs to know what you're passing in. Because, I mean, not functions, but different types of networking interfaces and protocols. The next part is to configure the server socket parameters. So our server address struct has a SIN family, which means the family type of the network. And in our case, it's AF-INET, which again means that it's IPv4 Internet Protocol. Next, it has a port, which in our case was actually passed in. Sometimes you can just hard code this, which is why I have this. And if you want to hard code it to 21750, you just want to use the host to network short to convert this into network order. And the next part is to assign the IP address, which you do it by writing to the syn address .s address. And we again pass this in through here. And another thing that you can do is just do the host to network long for in address any or in address loopback. And I do want to talk about this real quick, so let's go look at it. If you go into the /user folder on your Linux system, you can search for in address any and then include .h files. And we can see the in address any is defined as OX0000, and it will just mean that you can listen on any interface. If you want to search for loopback, we can again search for loopback also. And in address loopback is defined as OX7F000001, which is just 127.0.0.1. In our case, I'm letting the user pass in what address they want to listen on, just to give a little bit more power to the user when they call the program. And I wanted to also take a look at how this structs are defined. So if we grep for struct sock address in and then include that h files, oops, pasted it twice. So it's right here, struct sock address in is defined. Actually, let's look at the one for C, not for Linux. In the net, inet in.h files. So we have our sin underscore port, which is what we wrote to right here, the port number. Next, we have a struct in address, sin address, which is the internet address. And because this itself is a struct, so this sin address right here, we need to find this struct and write to it. So let's go ahead and find where this struct is defined. So again, we'll just grep for in address. Oops. So grep for struct in address. And it's defined right over here in the in.h file. Struct in address, it's just a 32-bit number, which is s underscore address, which is why I write to s, u dot s underscore address. And I write the IP address to this. So now that our struct is configured for the server address, we need to call bind to configure or to connect the file descriptor that's stored inside of FD to the IP address and the port of what we specified up above. So to do this, we call bind, passing in the file descriptor, passing in the server address, which again comes from my server params, and I pass in the address of it, and I pass in the size of the struct, which is sock address in, because bind handles many different types of protocols, so it needs to know what's the size. And the way bind will work is that it will look at the size, and it will also look at af underscore inet, and once it knows what this is, what valid this is, it will then handle it properly. So that's why we pass in the IPv4 inside of here. So once bind returns successfully, then our file descriptor is connected to the IP address and the port. And in this case, we'll assign the server params, the socket file descriptor as the FD because everything returned successfully. So let's go look at configure server. So we called it right here. So once this returns, and I really should be doing some error handling here to check if it's 0 or not. So I would recommend, let's add it in. Return equals this if return is 0. So if less than 0, we'll just print an error message. Error configuring server. And that should be good enough for us. Let's make sure return is defined. Awesome. I have int return equals 0. Perfect. Next step is just start the server. So let's go look at our, and again, it's taking the server parameters. So let's go look at our function. The server parameters will simply call listen using passing in the socket file descriptor. And 1 is the backlog for the number of queues that we will listen on. Let's go look at the man pages for listen so I can explain it a bit better. So passing, it gets the backlog, and the backlog means means it's the argument that defines the maximum length to which the queue of pending connections for sock FD may grow. So in English, this means that before you handle the queue or a connection, there is a set amount of connections that the operating system may accept, and then this is defined as 1. So if I were to define this as 5, the operating system will accept up to 5 connections, even though my program itself has not accepted anything, and it will only accept up to 5 now. And this is useful if you're running a production server and you have lots of connections. You'll want to set this to something high so that by the time your program handles it, you don't want to lose a connection. In my case, I'll leave this as 1. And if the call to listen fails, I want to handle it by first closing the socket file descriptor since it was open and setting the file descriptor to -1. Afterwards, I'll just return error, which is probably going to be 0 if it was successful, and it'll be -1 if it failed. So at this point, after this call, the server is listening on the file descriptor or the IP address and the port number, but my program is not able to accept anything yet because I haven't called accept. So let's go back to our main function. So we started the server. At this point, we need to call accept to accept the connection. So let's go look at the accept connection server function, which again takes the server parameters. Struct. So accept connection on server. So the only thing this is doing is it's calling accept, and we need to pass in the socket file descriptor. And the next part is we can pass in null for both of these flags or arguments, or we can pass in a struct pointer to the client address and a pointer to the length of the struct. So this is if we want to get some information about who connected to us. And this call will block until a connection happens. So if there are no connections in the queue and we call accept, then we'll just get stuck until a connection comes around, and then it will return the file descriptor. And the file descriptor returned is the file descriptor of the new connection, because we are listening on, like, for example, 21.750, but once something connects, it will create a new file descriptor for the to manage the connection. And there are 2 methods of getting the client address. The first one, as done here, is to pass it into the accept call. And in this case, I can just print client details 1, the file descriptor that was returned, and the address of the client and the port number. And the second method is to use get sock name, and again pass in the file descriptor and the client address, which is just a struct sock address in, and we can print the details of this method. And the reason why I'm showing you 2 methods of doing this is because they do slightly differ in the results that are returned, so I want to cover both of these. And again, this is the client address 2.sendAddress.s address, and we want to print this as a hex number because otherwise we'll just get an integer. And we use N2HL, which means network to host long and network to host short, to convert the IP address and the port and network byte order into host byte order. And afterwards, we return the file descriptor, which is the file descriptor of the new connection. So we want to verify that the connection that we accepted, if we did, is 0 or more. So if it's less than 0, that means there was a failure. Otherwise, we'll print that a client connected to the server. And we have 2 functions that we can run, which is the first one is run server reader or run server talker. So let's just focus on run server reader first, which will it will take the file descriptor of the accepted connection. So let's go look at it. So the connection file descriptor, and all what this will do is call a while loop, which will call the read function, and then we'll pass in the connection file descriptor, the buffer, which is just a char buff, and the buffer size -1 because we want room for the for the null byte, the end. And if it's greater than 0, then we know how much the server read, because this will return the amount of bytes read. We want you to set the last byte to the null byte so that we don't get any buffer overflows. And then we want you just print if info logging is enabled, the server received X amount of bytes, and print the server received the string that was received. And afterwards we can call B0 if you want, and this is optional because we are using the null byte, but we can do it for fun. So let's go ahead and test our server by first compiling it by running make, and then let's go ahead and run the messenger with the server flag. We can listen on localhost, and we can pass in, for example, let's do 45,025 as our port. And let's go ahead and test our server by using netcat, just as how we did it in the beginning. Let's use this tab right here. So we chose 45,025 for our port. And here we got client details 1. So the address is 0x7f, which is 127.0.0.1. And client details 2 again prints the same address. The only difference is in the port number that is returned. So let's actually go ahead and look at this a bit closer. Right here. So the first one returns 35,328, which is the new port number that the client and the server are talking on, whereas the second method, which is getSockName, it returns the port number as the port number that the server is listening on. So this one is, so they're both accurate, they're both true. It's just a matter of do you want the port number that the server is actually listening on, or do you want the port number that's the actual connection is on. And let's actually go ahead and turn this off and rerun this by passing all zeros. Let's go ahead and turn off our client. So run our server, and again connect to here. And so now our port number changed to 40,264, while this one is the same because that's what we're listening on. So now let's go ahead and check if our server reader is working, because it should read the bytes from the client and it should print them out right here, printf the buff. So hello, I'm the client. So hello, I'm the client. And the reason why I didn't print right away is because I ended up doing this, which messes things up. So hi, I'm the client. So 18 bytes, hi, I'm the client. Goodbye. And so far we haven't written in our server anything so that it will read from standard input and return and write to the file descriptor. So it's not going to write anything. We can instead do bye. And if we go ahead and kill this, it will think that hi, I'm the server is trying to be passed into the shell, and it obviously isn't, so it didn't work. Okay, so now that our server is running, Let's take a look at the run server talker function. So let's go ahead and comment this out and run this one. So this function will run in a while loop, and it will read X amount of bytes up to buffer size -1, which we actually defined right over here as 1024. So we'll set the last byte read as the null byte or the one afterwards, and then we'll print this to standard std out so that we can see what we read. Afterwards, we'll read from standard input using fgets, and it will send the input to the client. So now we have a small one-way talker, or both ways, but once at a time because of the blocking nature. So let's go ahead and run this. So here is our server, and here is our client. So we connect it, and let's write hi, I'm the client. And now the server will write hi, I'm the server. And so we can talk back and forth. And one thing to notice, because this is blocking and I'm doing this, either this followed by this, we have to go back and forth in our code. We can't just do it together. In other words, if I type in 1 here, I have to type in 2 here. And if I do 3 here, it works. Now if I do 4 on this one, I don't get it. But if I write 5 here, I will afterwards get the 4. That's because this is first running the read and the write by using doprintf, or we can have just used write also. There's many ways of doing this, but it's going back and forth. And in the future, we'll turn this into a non-blocking method so that it can work either way. But for now, there's this limitation. Okay, having covered that, let's jump into our client and get through this quickly. Let's make sure this file is saved. So our client is right over here, run client with the IP address to connect to and the port to connect to. So run client will first initialize the server parameters. So I'm creating this right here. Afterwards, it will configure the client. So configuring the client, it will be done by, let's see, we passed in the IP address and the port number. So right here, IP address, port number. I do some basic error handling. If it's the IP or the port is null, return -1. And over here, I do not recommend this code, but I did this so that we can take a look at the difference between the server code and the client code. So notice I'm using the A2I, which is ASCII to integer function, and there's no error handling here at all. If something were to fail, it would be the connect call. When we run this will fail if there is an issue. But I personally would prefer to catch errors a lot more earlier. So the proper way to do this will be to not use A2I, but to go look at the server code, which, like, I have A2I commented out here, and I'm using all of this. This is the proper way of handling the port number conversion from a string to a number. But this is, like, if you look at Google, this is most of the code you'll see is this, and this is just really bad. And same thing here, inet address. You can if you start looking at Google, you'll see a lot of this. It's not recommended. It's clean, it's short, but there's no error handling. The proper way is what I showed you right over here, is using this function, get IP address, and checking for an error, and my get IP address was defined over here, and I've showed you the inet address is commented out because I prefer to use inet ASCII to network order and check if the IP conversion from a string to a number was valid or not. So just something to keep in mind before you copy this code. Make sure to convert it to what I did for my server. But having said that, so what we do is we create a socket using IPv4 and sockstream for TCP IP. We make sure our socket is not less than 0. So go ahead and save it. And then we configure our server address to be a TCP IP or to be IPv4 to family, and take the IP address and the port number and return 0. So now that we have a socket now, and we have the struct for the server address is created. So if everything was successful, we move on to run connect client. So connect client will simply call connect with the socket file descriptor and a pointer to the server address and the size of the struct. So this will also block until a connection is made, or it might fail if it was not possible to connect. So we can actually take a look at what happens if there's nothing by just testing it right now. So for example, if we run client and 50,123, error, call to connect failed, connection refused. That's because there's nothing listening on here, so this will fail if there's nothing connected. However, if we were to run our server on port 50,123, we can now connect to it. So connect will return 0 if successful. So we'll return 0 if it was successful, otherwise error. And if there was an error, we will set the file descriptor to -1. And again, before we do this, one thing that is recommended is what we did for the server. So let's go look at this before I show you what I'm going to change. So right here, if listen was to fail, I would first close the socket file descriptor and write -1. So we do want to do the same exact thing here. So let's go ahead, close on server params. Socket file descriptor. And then we'll set it to -1 and return error. Okay, so now that we're connected to the client, we'll print that the client connected to server, and we have a few functions that we can run. So let's look at the first one, which is the run client sender. And to do this, I want to change my server code also to run the server reader. So run client sender will simply write sending a message to the server and sending a second message to the server. So let's go ahead, close this, compile. And run the server, run the client, and we send these two messages, sending a message to the server, sending a second message to the server, and then exit it. So now let's go ahead and change this again to run client standard input sender. And what this will do is it will read from standard input and write to the server. So hi, I'm the client. Goodbye. And so it's working. So let's go ahead, turn this off, and let's run next one. So run client talker. This function will run in a while loop, and it will read from standard input and send to server. Afterwards, it will read from the server and write to standard out. So let's go ahead and run this. Hi, I'm the client. Hi, I'm the server. And this is not working because we forgot to change the server. So if I were to write goodbye, I should be able to see it here. No, because my client is stuck waiting for a response from the server. Let's go ahead, fix our server code by running this one, run server talker, so we can go back and forth. Let's go ahead, clear this out, and okay, hi, I'm client. Hi, I'm server. Okay, so now we're going back and forth. Goodbye. Wait. So if I were to write what, now if I were to write again, this would not come because we're stuck in the state where we're waiting for the server. So we write 1, 2, 3, and now we get the again message. So in the next video, we're going to cover how we can turn our run server talker to use non-blocking sockets. So that way we can write messages back and forth instead of one at a time. But for now, we'll just leave it at that. And I hope you guys found this video helpful. If you have any questions, just drop them in the comments. If you are interested in how to create a makefile, I can cover that. Just drop it in the comments. But for now, we're going to start focusing on non-blocking sockets for the next part. And with that, I hope you guys learned something useful and have fun. And I hope you practice this type of code yourself. Goodbye.